last time, maybe I'll show you this one more time. For a question like number 4, remember this principle, that if you have a base and the exponents are a sum, kind of like the top here, if you're adding exponents, what are you really doing with the bases? That's right. So the top is really 3 to the n times 3. And this will go a long ways towards helping us identify a common ratio. We can see that we have a numerical base, variable exponent. So it's definitely geometric, or at least has some geometric element in it. The 3 can come out. And so we end up with 3 to the n over 4 to the n. Okay, so I'll let you guys run with it from there. In taking this here, you guys comfortable with that? Okay. So then, once we get to here, we need to identify the common ratio. What do you guys have for a common ratio on this one? 3/4. Yeah, so R equals 3/4. And 3/4. 3/4 is between 0 and 1, is it not? Last time we checked, yeah, I think so. Okay, so we could say, therefore, by the GST, the series converges. And if you wanted to do what Darian did, you could actually figure out what the series converges to as far as the number goes. So we would say sigma, 3 times sigma of that would equal, so it'd be 3 times the first term over 1 minus the common ratio. So that 3 here is the same as that 3 there. We're just multiplying the whole series. Sum by that. Of course, it just makes the top 9/4. So you'd get 9/4 over 1/4. So I would say you'd get 9er. Good?
Are there any practice problems where you ask for us to do that? To like practice?
Do you have to know how to do that? Absolutely you do. We're just kind of picking it up along the way, doing a couple of practices. Sorry? You probably learned, you should have learned it in pre-calc. And I showed it to you again. So yeah, you definitely want to know how to do that. Okay, take a look at number 5, please. 5 to the n over 3 to the n plus 1. Taking a look at number 5. You could do number 5 in 2 different ways. So if you see one way, that's great. See if you can figure out what the other way might look like. There's at least 2. Well, there's more than 2, but so far of the 2 you've learned, you could do both of them. Just think about how that might work. Coming up with for a common ratio.
5/3.
5/3 is right, yeah. So this is geometric, based on the idea that you got numerical bases and variable exponents. You could, if you wanted to, you could pull the 1/3 out and say you've got 1/3 sigma from 1 to infinity of 5/3 to the n. And then you'd say, all right, well, r equals 5/3, and that number is greater than or equal to 1. Bless you. So if the common ratio is greater than or equal to 1, you can say, therefore, by the GST, the geometric series test, the series diverges. Let's try that again. The series diverges. And so that formula for finding the sum of the series doesn't apply here because it diverges. The answer, quote unquote, would be infinity or does not exist. So you'd get a diverging answer. Did anybody think about the nth term test for this one? Think of it like this. You could have done this. This would be perfectly acceptable. You could say the limit as n goes to infinity of 5/3 to the n. Start thinking about what these terms would do. 5/3 to the 1, to the 2, to the 3, to the 4. Isn't the result just going to get bigger and bigger and bigger and bigger? So you could say this doesn't equal 1. Or doesn't equal 0, sorry. It doesn't equal 1 either. It doesn't equal 0. It actually is increasing without bound, right? And so since the nth term is not heading towards 0, you can say, therefore, by the nth term test, the series diverges. So either way would work. There's some flexibility here, right? Certain series could be worked on with different tests. Okay, take a look at the ball question. This is just a little application. It says a ball is dropped from a height of 6 feet and begins bouncing. Each bounce is 3/4 the height of the previous bounce. Find the total vertical distance traveled by the ball. Right? The temptation would be to say, well, just like keeps bouncing and bouncing and bouncing, never like stops, would be infinite. We can actually use math. We can use what we've been working on to help illustrate this. So, you guys looked at this yet? You get done early with the other one and look at it? If you haven't already looked at it, go ahead. I'll get zoomed in here a little bit better, zoomed out. There we go. I think a picture is nice here, but you're eventually going to have to work your way back towards series and numbers and stuff to help you out. So take a minute, think it over. We'll go over the solution in a minute. If you draw a picture of this, doesn't the ball start at its highest point? It's like this first drop is 6 feet, right? First drop is 6 feet. There's the floor right there. And then the bounce up, isn't it going to be 3/4 of 6? But then isn't it going to drop 3/4 of 6? So it's going to go up 3/4 of 6, and then it's going to drop 3/4 of 6. And then on the next bounce, I'll just continue over here. The next bounce, isn't it going to go up right here? Wouldn't it be 3/4 of 3/4 of 6? And then isn't it going to drop down the same amount? So basically forever, it's going to basically be multiplying by another 3/4 for each successive bounce. That's what makes this geometric. So here'd be the formula. I look at that first drop of 6 as sort of being the outlier. Right? There's only one of them, but for all the rest of them, aren't there 2 of them? So I would say 6 plus sigma, and I don't know, I'll probably do n equals 1 to infinity. I mean, you could make this work without that. But then each bounce is going to be 6 times 3/4, right? So we're going to have this 3/4 to the n. That's going to be our common ratio. But then 6, right? It's going to be 6 times 3/4 each time. What's easy to forget here is that for every bounce, isn't there going to be a symmetry? There's going to be a 3/4 n up and a 3/4 n down. And so the key that sometimes people will forget is there needs to be a 2 in there. Because do you notice how there's 2 of them each time? 1, 2. And so if you work this out, you end up with 6 plus 12 times sigma of 3/4 to the n. So let's see here. This would work out to be 6 plus 12. The first term would be 3/4. And 1 minus 3/4 would be 1/4. So I'm getting 6 plus 36, 42. 42 feet for the total vertical bounce. Sorry we had to rush through that. We ended up bumping up against our time a little bit there. A little application, probably not a big focus of series stuff. I just thought I'd throw something in there that provides some form of application at this early stage. Okay, have a wonderful day. I will look forward to seeing you guys tomorrow. Tomorrow we'll tackle the, you guys remember the p-test from before?
Yes.
We're going to revisit the p-test, and we'll also talk about something called the integral test.